Welcome back. So in this second half of chapter 8, we're going to start moving on away from graphing and we're going to get back to the strict algebra about these rational expressions. Now, today's focus is learning how to simplify rational expressions and how to multiply rational expressions. So, the thing to keep in mind when we're dealing with rational expressions, and I know you've heard this before, the idea is we're going to have restrictions whenever we do this. All right? A restriction is a value you can't use for the variable because you'd end up dividing by 0. All right? Now, there's two main simplification methods. All right? One of the methods deals with when you have monomials. Okay? So, when you're dealing with a monomial in the denominator, and what that means is no pluses or minuses on the bottom. Okay? When you have that, just simplify the rational expression. So looking at this one, 24 divided by -6 is just -4. X cubed divided by x squared, subtract the exponents, 3 minus 1, or 3 minus 2 leaves me with 1. Y squared divided by y cubed. 2 minus 3 leaves me with a -1, which means that y is going to be in the denominator. So this is what the simplified expression looks like. In terms of the restrictions, well, as my little note up there says, that when you have monomials in the denominator, all that means is that the variables can't equal 0. Those are your restrictions. So each of these is going to have two pieces to your solution, the simplification and the restrictions. Now, what I want you to notice is something very interesting. Your restrictions came from the original denominator, not the simplified denominator. That's going to be very important throughout this lesson as you're working on these. Restrictions are from the original denominator, not the simplified one. Okay? So let's take a look at our next example. So in this one, I can factor out of the top, all right? So both the 8 and the 12 are divisible by 4. And there's x's in both of them, x cubed and x. So I'm also going to pull an x out. So 8x cubed divided by 4x, I'm pulling that out. Well, 8 divided by 4 leaves me with 2. X cubed, take one of those away, leaves me with an x squared. 12 divided by 4 leaves me with 3. X, take away that only x, leaves me with that. And then we still have that denominator. And the neat thing is, by pulling that out, now I can go like that. And all I have left is 2x squared minus 3. All right, so that is my simplified expression. My restrictions, well, restrictions come from the original denominator. Here, the original denominator is a monomial. So if my x is 0, that would automatically make the whole thing 0. So again, whenever the denominator is a monomial, you can just set that variable equal to 0. That becomes your restraint or your restriction. Now, most of the factoring we're going to do looks like this bottom piece. So the focus of our lesson is on these bottom ones, okay? And I've tried to be very intentional with these. I've tried to make sure that I include all of the different factoring methods that we've encompassed because every one of them is coming back in this chapter, okay? So, for example, this first one, okay, the top, I can just factor out a greatest common factor. I can pull a 4 out of both of them. Okay. On the bottom, that is just a normal quadratic trinomial. So that is my 2 parenthesis factoring. Okay. Multiplies to -18, adds to -7. So, I'm sorry. So that's going to be x minus 9, x plus 2. All right. Now, before I finish it, before I start canceling, this is a good place to take care of your restrictions, okay? Before you cancel, because remember, it's the original denominator that matters. So, after we factor, but before we cancel, let's take a look at these. This piece, what would make me divide by 0? Well, 9 would make me divide by 0. How about in that one? Well, a negative 2. So every time you go to do these problems, after the factoring, but before you cancel, it's where I'd like you to pause and take a moment to make your restrictions. Now, let's finish this process. Now I see two things that are the same on the top and bottom, so I slash them out, and I simplify this to 2 over x minus 9. So again, the blue is my simplified expression. The green are my restrictions. It takes both of them to have a complete answer. All right, so let's look at our next one. Our next one, again, the top and the bottom have different factoring methods to help you recall what we've been working on. On the top, that's the greatest common factor, is the greatest common factor that has an x in both terms. So the greatest common factor here is actually the x. So I pull an x out of both of those, so the x squared becomes x, 3x just becomes 3. The bottom is that model of the difference of squares. I have two perfect squares being subtracted, so remember that setup. That's where you get your plus and your minus. The x squared comes from x's. The negative 9 comes from 3's. All right, and again, post-factoring, but pre-canceling, I'm going to make my restrictions. All right, I look at this piece of my denominator. What would make that divide by 0? Well, if x were negative 3, I'd be dividing by 0. This piece right here, if x were positive 3, I would be dividing by 0, and I want to make sure I don't do that. So, label those restrictions. Now, I make my cancellations and write my simplified expression of what I have left. And again, making sure that you have both pieces for me, the simplified expression and the restrictions. Okay, and I'm sorry, let's box that up. All right, last one. So here, let's factor the top. Again, the top is just linear, so that means all I can do is factor out a 3. Pull a 3 out of both of those, well, that becomes a 2x and a 1. The bottom is a normal 2 parenthesis factoring. Okay, however, if you notice, this time a isn't 1. Okay, and so when a isn't 1 is a little bit more complicated. Now, what I noticed though is with this 4 and that 1, both of those are perfect squares. Okay, so I'm going to take a guess that this is one of those perfect square trinomials. Again, it's a really good place to start, and then if you're wrong, you can always go back and fix it later. Okay, but let's see. I have 4x squared, I have 1, and then I have 2x plus 2x to give me that 4x. So if you notice, when you try out the perfect square trinomial format, you actually do end up getting what you're supposed to. Okay, so that's another method to remember. When a isn't 1, make sure you remember how to check those connections to make sure you're getting the right answer. Okay, so now let's pause a moment and talk about our restrictions. So here, when is that going to be 0. Now maybe that's a little bit harder for you to see. So for that one, if you need a little scratch work, so 2x plus 1, when is that going to be 0? Well, subtract the 1, divide by 2. Oh, that's right. X can't be negative 1/2. So remember that you can go and actually do some of that math to check. If it's not obvious like those other ones, then please make sure to show that little bit of scratch work to find what X would make that piece 0. Now, here I have a case where I have the same thing again. Okay, I have another 2x plus 1. So if I have the same factor, it's going to lead to the same restriction, and I don't really have to show that. Okay, once the restriction is on my list, it's on the list, so you don't need to repeat it. Okay, so the only one I have to show is the negative 1/2 once. Okay, don't feel the need to show it again. And now, let's cancel those up. So my simplified version is going to be 3 over 2x plus 1. All right, so that's what our simplifying process looks like, okay, if I give you a rational expression. So the other piece of today is working when we're multiplying expressions. So multiplying works the same way, okay? Factor each piece up and then write your restrictions, then cancel. Now, the key that I'm going to help you with, okay, the thing I want you to do right away, put parentheses around everything. Okay, that's what I used with my kids in the past, and it really helps them make sure that they're only canceling when they're supposed to. Okay, because you don't want to be one of those mad slashers that starts canceling too quickly. You can only cancel if the entire parenthesis is the same. Okay, you can't cancel a piece of a parenthesis. The only way to break a parenthesis is through factoring. Okay, so for example, that top piece, okay, that first piece, that 6x minus 4, I can pull a 2 out of that. So when I do, I get that. Okay, so I pull a 2 out of the 6x minus 4, just a greatest common factor. That x minus 5, I actually can't do anything with. So that just gets to stay. That x squared minus 5. Well, that should remind you of our difference of squares setup. Two perfect squares being subtracted. So to factor that, remember difference of squares gets me the plus or minus pattern. The x squared comes from x's, 25 comes from 5's. Okay, and the bottom. The bottom is our normal two parentheses factoring, but notice a isn't 0. What I am noticing, though, is two perfect squares, okay? 3x giving me the 9x squared. 2 is giving me the 4. The negative there tells me those have to be negative. And again, it doesn't always have to work this way, but it's a good place to start, a good place to check. Let's see if that worked. Negative 6x, negative 6x, that did give me the negative 12x in the middle. So using that structure actually did end up working. That is what I was looking for. Okay, so remember each of these techniques. Each technique is critical in solving these. Okay, so now let's take a break and let's write out our restrictions. So remember, we pause at this step to write our restrictions from the original denominator. That right there is telling me x can't be 5, because if x were 5, that would be 0. This next one, well, that next one is one of those more complex ones. So again, this is where I recommend you just set it equal to 0, do the quick algebra, add the 2 over, divide by 3. So you can see where that 2/3 comes from. Don't try to do too much in your head, okay? It'll end up messing you up in the end. And of course, I have two of those same things, so I don't need to write it again, right? I only have to write it the one time right here. And now let's do some cancellations. Okay, the 3x minus 2, 3x minus 2, x minus 5, x minus 5. So what does that leave me with? Well, on top, I have 2 and x plus 5. On the bottom, I have 3x minus 2. Okay, so even when you're multiplying, it's still that same thing. Anything on the top can cancel with anything on the bottom as long as they're the same thing, the same expression. Okay? And again, I have both of my pieces, restrictions, and I have the simplified expression, so that means that I am done with this example. So let's move on to our next one, our final example of the day. Again, we need to factor everything. So let's start in the top left, x squared plus 4x. So there what I'm noticing is there's an x. Oh, I'm sorry. I actually broke my own rule. I forgot. The first thing I want you doing, put parentheses around everything. Okay? Because with those parentheses, that'll remind you that the only way to cancel is if an entire parenthesis is the same as another entire parenthesis. So make sure you put those on there. That's the first thing you should always do. Okay? Stack them up with parentheses. All right, x squared plus 4x. I see an x in both terms, so I'm going to pull that x out, turning the x squared into x, the 4x into 4. The bottom, okay, the bottom resembles that difference of squares factoring. That gives me the plus or minus. The x squared comes from x's, the negative 16 comes from 4's. Okay, the x squared minus 3x minus 4, that again is normal two parenthesis factoring. Now here, a is 1, so the x squared doesn't have coefficient, so that's going to make this a whole lot easier to do. Two things that multiply to negative 4, add to negative 3, we're going to have a minus 4 and a plus 1. The bottom is again normal two parenthesis factoring. And two things that multiply to 16 add to 8 is going to look like that. All right, so a lot of stuff going on the bottom here. So let's take a moment, let's pause to do our restrictions. Okay, so here, x plus 4 is going to make a restriction of negative 4. X minus 4 is going to make a restriction of positive 4. And notice these over here are exactly the same as what we've already done. Repeated factors would repeat restrictions, which you don't have to write out. Okay, so you can just leave it like this. And now we can start canceling. So x plus 4, x plus 4, x minus 4, x minus 4, and it looks like that's it. So on top, we have x and x plus 1. On the bottom, we have x plus 4, x plus 4, which if I even wanted to write that a little bit cleaner, I could write that as x plus 4 squared. Okay, and that would be my simplest way to write my expression. All right, so as you can tell, a lot of factoring in this section, okay? However, all the factoring should be completely doable because the factoring piece is the review from what you've already done, okay? So I want you to now pause, write your summary for me, okay? So take a moment, reflect on what we just talked about, write your summary, whether it be about the restrictions, the different factoring methods, whatever you think you need to remember. And then make sure to come back ready to do your practice work.